Last thing we're going to talk about all together, and then I'll stick around for questions. So this problem is very similar to question number 3 on the 1.3.4 summative assessment. This is an actual picture of my garden. So I'm big into plants. Don't know if you can tell behind me, but I made all these babies, propagated them. They'll change throughout the year. All these different, this is my plant nursery behind us. They'll change as the year goes on. Anyways, this is what my garden actually looks like right now in real time. I just planted beets and carrots, broccoli, and kale, because all those are fall, winter vegetables. So that's why they're so little. However, I have a problem with rabbits. So I want to put a fence around it, and I want to have a gate at one of the shorter ends. Okay. So here's my problem. I asked my kids to help me measure and do all that. And then my 8th grade son, who has horrible handwriting, he was the one who wrote all the information down. Well, I can't read it. So here's what I know. Mrs. Fergus's veggies keep getting eaten by rabbits. She wants to put a fence around her garden and have a gate at one of the shorter ends. Okay, you see one of the ends, I want to have that gate on. So one of these shorter ends. Oops. Her children helped her measure, but Miss Fergus can't read the handwriting with the measurements. She knows the total distance around is 42 feet. What's another word for total distance around in math? Throw it into the chat if you know. Total distance around. It's a really important word in math. In a circle, this distance is called the circumference, but with any other shape, we use a different word called the perimeter. So I know the perimeter around the outside is 42 because I can read that much on my paper. I also remember when we measured that the longer sides were 5 feet longer than the shorter ones. But that's all I know. Help Miss Fergus calculate how long the gate will be on the short end of her garden. Dun, dun, dun. It's a math mystery. Okay. Believe it or not, we have enough information here to help Miss Fergus figure out how long my gate's going to be. So whenever you are given a problem involving algebra, the first thing you want to do is label everything that you know. So I have a rectangle. So on your paper, you want to draw a rectangle, and we're going to label as much as we can. We know the perimeter around the outside, total distance around the outside is 42 feet. Okay, so we can get that information down. Okay, we also know a relationship between our longer legs and our shorter legs. My longer length was 5 feet longer, but we don't know the shorter length. So in math, if we don't know a quantity, what can we do? We just did it earlier today. We can define the variable. Does that sound familiar? All right. Whoever's the fastest person in chat can pick what variable you want to use for this problem. Oh, Megan wins. She wants to use J. Let's do it. All right. So for this problem, we're going to say J is our unknown quantity. Okay. J is going to hold the place for the length of the shorter side. So on your paper, you want to make sure you're writing this down. This right here, what we just did, this is called defining the variable. You're informing your reader what variable you're using and what it is holding the place of in our problem. So curious, Megan, why J? Just cause. It's fantastic. Okay, So since I have a picture, I'm going to label that on my picture. So rectangle, short sides are the same length. Yes. So I'm going to label both of those short sides J. Okay. Here's where the magic of algebra comes in. We know that the longer sides are 5 feet longer than my shorter sides. So then what algebraic expression can I use to represent my longer sides of this, of my garden? Nice, Ashton. So we're looking for an algebraic expression that we can use to represent the length of, nice, Charlie, the longer sides. Yes. Okay, so get those labeled on your picture. Your picture is provided for you in 1.3.4 summative assessment. Okay, but you won't always be given a picture, so we're making a picture together. Oh, Miss Fergus is clicking things on her pen. Stop. Get back down. There we go. Okay, now this is what we have. We now know a side length measurement for every single side length on my garden. And I also know all of these add up to 42. So that is enough for me to write an equation using all the information that I know. Let's do purple to celebrate, shall we? Okay, so we're going to write an equation. So the perimeter is going to be the sum of all 4 sides of our garden added up. So let's write that out. So J, so I've done that one, plus another J. I like to be organized, so I'm going to put my 2 shorter sides next to each other, plus a J plus 5, plus another J plus 5. So this is an expression that adds up all 4 lengths of my garden. We know this sum is what? Because I could read that on the paper. These sum up to what number? 42. Beautiful. So this is quite the feat, what we've done. We have now taken all of our information and we've used their relationships to write an equation. Now, your job is to simplify the equation and solve the equation to figure out what J is. So do we know how, just cover up the 42 for now. Look at the left side. Do we know how to simplify J plus J plus J plus 5 plus J plus 5? Can we simplify that in algebra? You can. So combine your like terms. Go ahead and do that. Simplify that left side. I'm going to circle my like terms. So I have 4 J's. All right. Go ahead and simplify that left side of the equation. What are we left with? J plus J plus J plus J is going to be 4J plus, what's our plain number we're going to have in this equation? Good. $4J plus 10, love it. Okay, questions on where either the 4J came from or the 10? So we combined like terms here, just like we practiced last lesson. Combine like terms. Oops. Fergus, where did your pencil go? Maya, what's up?
I actually got the solution to what J equals to.
Perfect. Okay, don't share it out quite yet. We're getting there. I love that you're already there. If you have it in that chat, Sandy, go ahead and throw it in your chat. We know 4j plus 10 is equal to 42. Okay, so now we need to solve this equation. And we haven't yet practiced that here in Zoom. So this might be new. Okay. Okay, so whenever I have a two-step equation like this, we are gonna peel the onion is what I call this. Pretend like J is at the center of your onion. You have to peel your outside layers first. Get them away from the J in order for us to isolate J. So the thing we need to get rid of first is this plus 10. What's the inverse operation of adding 10? The opposite. Good. We're going to subtract 10 from both sides first. Plus 10 minus 10 goes away. And at this point, we are left with we still have 4j. I'm going to erase this and make some room. Boop. All right, we still have 4j equals, and what are we left with on the right side? 42 minus 10 is 32. All right, last thing to solve this equation. What undoes 4 times j? What's the opposite operation of multiplication? Division. So we're going to divide both sides by 4. Good. All right, Maya, what did you end up getting for j then?
I ended up with 8 being J.
Boom. Boom. Same with me. Okay. 4j. Good. So j equals 8. Okay, now, have I answered the question? J is holding the place for the shorter side length. Okay. And the question was, how long will the gate be? Well, we did answer it, didn't we? So the gate will be how long? Gate will be 8 feet long. Good. What if the question was, though, what's the length of the longer side? How are you going to use 8 and answer that question? What's the length of the longer side? Yeah.
I actually need to go now.
Okay. Sorry. Yep. We went a little bit over. All right. See you, Maya.
Bye.
All right. This is the last thing, and then we will go. What if the question was, what's the length of the longer side? How are we going to use 8 to find that? Well, we go substitute it in right here on our picture. And notice what we have, 8 plus 5. And there's our 13 feet. Okay, so this